Earth, our home planet, a tiny blue speck drifting in the vast cosmic ocean. Every person you have ever known, every story ever told, every human who has ever lived, all exist here. This is where our journey begins. As we move beyond Earth's atmosphere, past the Moon, beyond the familiar planets and the Sun, we embark on an epic voyage, a quest to comprehend the true scale of the universe. The first milestone on our journey is the Moon, approximately 384,000 kilometers away. To put this in perspective, if you were to drive a car at a steady speed of 100 kilometers per hour, it would take more than 160 days to reach it. From the Moon, Earth looks like a delicate sphere of blues and greens, cradled in the darkness of space, a humbling sight that reminds us of the fragility of our existence. This is our planet as seen from the lunar surface. Moving farther away from Earth, our journey brings us to the Sun, the blazing heart of our solar system. It sits 1 astronomical unit away, a measurement defined by the average distance between Earth and the Sun, which is roughly 150 million kilometers. The Sun itself is a titanic sphere of incandescent plasma, powered by relentless nuclear fusion at its core. Every second, it converts about 600 million tons of hydrogen into helium, releasing an extraordinary amount of energy. This energy radiates outward through space, bathing the planets in light and heat. Past the Sun, we set our sights on Mars, the mysterious red planet. At its closest approach, Mars lies 54.6 million kilometers from Earth, but when the planets move to opposite sides of the Sun, that distance can grow to nearly 401 million kilometers. This immense distance explains the challenges faced by robotic missions sent to the planet. Our rovers and spacecraft travel through an ever-shifting maze of orbital positions and vast cosmic separation. Journeying further outward, we encounter Neptune, the icy giant framing the edge of the planetary portion of our solar system. Neptune sits about 4.5 billion kilometers away. Sunlight needs roughly 4 hours and 15 minutes to travel from the Sun to Neptune. This enormous distance demonstrates the grand scale of even our own celestial neighborhood. In 1977, Voyager 1 was launched, an embodiment of humanity's endless curiosity and desire to explore. More than 4 decades later, Voyager 1 has traveled over 22 billion kilometers from Earth, becoming the most distant human-made object in existence. In 1990, following a suggestion by Carl Sagan, Voyager 1 turned its camera toward Earth for one final look. The result was the legendary pale blue dot photograph. From around 6 billion kilometers away, Earth appeared as a tiny, faint speck in the immensity of space. Sagan reflected on this image with powerful words, urging humanity to protect and cherish our only home. At the farthest outskirts of our solar system lies the Oort cloud, a vast, theoretical region of frozen objects. This distant sphere may extend up to 100,000 astronomical units from the Sun, nearly 1.9 light-years. Its outer edge touches the threshold of interstellar space, where the Sun's energy and solar wind finally fade against the interstellar medium. The heliopause, this boundary, is where our solar system truly ends, and the realm of the galaxy begins. The Oort cloud marks the final frontier of our Sun's influence. As we venture beyond the confines of our solar system, our next point of interest is Alpha Centauri, the closest star system to our Sun, located about 4.13 trillion kilometers away. This distance is equivalent to over 276,000 astronomical units. At such colossal distances, the AU, a measure so convenient within our solar system, begins to lose its practicality. Hence, astronomers use the light year, the distance light travels in 1 year, for interstellar measurements. Alpha Centauri is about 4.4 light-years away from us. Considering our current space travel technology, a journey to Alpha Centauri is almost unfathomable. For instance, the Voyager spacecraft, traveling at about 17 kilometers per second, would take over 70,000 years to reach this neighboring star system. This immense distance underscores the vastness of space that separates the stars and highlights the challenges of interstellar travel. Our journey now takes us to the grand scale of our home galaxy, the Milky Way, spanning about 100,000 light-years in diameter. This vast spiral galaxy is home to hundreds of billions of stars, each potentially hosting its own planetary systems. Within this immense structure, there's a tiny sphere known as the human radio bubble, extending about 100 light-years from Earth. This bubble represents the farthest extent of human influence in the cosmos, the reach of our radio and television broadcasts. Beyond this bubble, it's as if humanity never existed. Any civilizations residing in the vast majority of our galaxy would be oblivious to our presence, given that our signals haven't reached them yet. The scale of the Milky Way is so vast that our entire recorded history is but a whisper in the cosmic wind, undetectable beyond this small bubble. As we leave the Milky Way, we enter the vast, almost incomprehensible realm of intergalactic space. Here, galaxies float in the cosmic ocean, separated by mind-boggling distances. Our galaxy is part of a small cosmic neighborhood known as the local group, a cluster of more than 50 galaxies spread across approximately 10 million light-years. The local group is a diverse assembly, including not just spiral galaxies like the Milky Way and Andromeda, but also a multitude of smaller dwarf galaxies. The distances here are so enormous that light from one end of the local group to the other would take 10 million years to traverse. This scale dwarfs anything within our own galaxy, underscoring the enormity of the universe. As we extend our cosmic gaze beyond the local group, we encounter the colossal Virgo supercluster, an immense collection of galaxy groups and clusters, including our own local group, encompassing a region of space about 110 million light-years in diameter, or 33 megaparsecs. The Virgo supercluster is a titanic structure in the universe, containing thousands of galaxies from at least 100 galaxy groups and clusters, each with its own myriad stars and planets. As we journey outward from the Virgo supercluster, we arrive at an even more staggering cosmic structure, the Laniakea supercluster. This immense congregation of galaxies, which includes the Virgo supercluster and extends over 500 million light-years, is our galactic home on a grand scale. Finally, we reach the boundary of the observable universe, an awe-inspiring sphere stretching roughly 93 billion light-years in diameter. This leads to an intriguing question: how can the universe be 93 billion light-years wide if it is only 13.8 billion years old? The answer lies in cosmic expansion. Space itself has been stretching since the Big Bang, causing distant galaxies to recede faster than the speed of light. Many regions lie beyond our observable limits, forever hidden. The true size of the universe remains unknown, possibly infinite. The observable universe, as immense as it seems, may just be a tiny portion of the entire cosmic expanse. Countless galaxies, stars, and wonders may forever remain beyond our reach, drifting away into the endless expansion of space.